Hello everyone, my name is Christina and welcome to video 14 in our A-level mathematics calculus series. We are differentiating composite functions using the chain rule and this is part 1. So the objectives of this video are to recognize how the chain rule allows you to differentiate composite functions. For example, y equals 2x plus 1 cubed. And then we're just going to apply the chain rule to this function to differentiate it. So let's start with a bit of a definition and explaining what the chain rule actually is. So the chain rule allows you to differentiate composite functions. So let's say we do have a function y. So y will be our composite function and y is a function of another function u. So that goes back to our definition of composite functions. It's a function within a function. And so if y is a function of u, but then u is a function of x, then we can say the chain rule gives us dy over dx equal to dy over du times du over dx. So when we differentiate our composite function y with respect to x, we can differentiate our function y with respect to u and then multiply that with the differential of our function u with respect to x. Let's try and contextualize this with an example. So in this example 1, we want to use the chain rule to differentiate y equals 2x plus 1 cubed. So I've already started writing it here, but let u equal 2x1. So u is our function inside our function y. And it's equal to 2x plus 1. So now we can clearly see that y is a function of u and u is a function of s. So let's rewrite y equals u cubed. So if we want to differentiate y, we want to do dy over dx, let's follow the chain rule. Let's first do dy by du. So let's differentiate our function y with respect to u. That's easy for us to do because we let u equal 2x plus 1 inside the brackets. So all we need to do now is differentiate this term u cubed with respect to u. And so our usual rules for differentiating powers of a variable apply. So it's the same as when we were differentiating powers of x. So let's bring down the power. So we get 3 times u and then take away 1 from the index here. So that's 3u squared. So that's going to be our dy over du. And now we want to multiply this by du over dx. So now remember, y equals u cubed, but u is equal to 2x plus 1. So du over dx means we want to find du over dx, we want to differentiate u with respect to x. So we want to differentiate 2x plus 1 with respect to x. And again, the same rules apply. If we're working out du over dx, we differentiate each term with respect to the variable x. 2x differentiated is just 2. And then when we differentiate a constant, we get 0. So du over dx is just 2. So we times by 2. And that is our du over dx. So following the chain rule, dy over dx is equal to 3u squared times 2. That's 6u squared. So in function notation, we can also write the chain rule. If y equals f of g of x, then the chain rule can be written as dy over dx is equal to f dash of g of x multiplied by g dash of x.